Hello, welcome to my final year project video about production of biogas from flower waste in Sri Lanka. In this video we will walk you through a simple explanation about problem statement, how to set up laboratory scale biogas unit, and its functionality. This research focuses on assessing the feasibility and optimization of biogas production from flower waste in Sri Lanka. So, let's get started and dive into the details. Flowers are generally used in religious places and used as a raw materials in industries. After generated flower waste, improper disposal creates environmental and health problems. Generating biogas from flower waste can contribute to sustainable energy provision by exploring pretreatment techniques. Firstly, design and construction laboratory scale biogas setup. Then flower waste collection, separation, shredding. After that, total solids, volatile solids and moisture content test, pretreatment, create inoculum, then flower waste feeding, monitoring parameters, biogas production, and finally measure the biogas yield. This biogas setup mainly consists with three parts, which are biogas digester, gas collector bottle, water displacement bottle. Because to measure the biogas yield, I use water displacement method. Black color digester controlled its inside temperature. Flower waste collected from near two temples. Below two charts show the types of flower percentage, which include 1 kilogram of flower waste from those two temples. Those collected flower waste was separated using the characterization of flowers. I selected 500 grams of marigold flower waste and 500 grams of mixed flower waste to this study. Mixed flower waste shredded using an electric grinder. Marigold flower waste petals are shredded by hand. Moisture content, total solids, and volatile solids are most important parameters of feedstock to produce biogas. Higher total solids, volatile solids, and lower moisture content directly impact to the higher biogas production. Various pretreatment methods used in the world, such as physical, chemical, and thermal. So, I choose chemical pretreatment method using sodium hydroxide for this study. Pretreated using 50 grams of sodium hydroxide mixed with 1 liter of water, soaking for 24 hours. Prepare the inoculum using buffalo dung mixed with water, then fed to the digester to create initial microbial culture. After the inoculum period, flower waste fed to the digester. Monitoring parameters such as pH level and pressure level using pH papers and homemade water manometer. Biogas yield identified by water displacing between the gas collector and water displacing bottle. The biogas flame test was conducted using the valve. Finally, biogas volume was measured by daily recording its scale readings. Now we look at its functionality. First, add buffalo dung mixed with water using a feeding pipe. Generally, 14 days is considered an inoculum period. After the inoculum period, added the pretreated and untreated flower waste. This study was carried out over a period of 87 days with inoculum period and without daily feeding. There were 4 phases. Each phase carried out 20 days. Daily biogas yield reported by subtracting biogas production from inoculum. An assumption made in general was that after 20 days, feedstock would have a weak gas production potential due to a drop in their sugar content. So, the produced biogas comes through this line. And it came to the gas collector. The gas collector bottle is filled with pure water. Due to the biogas pressure, it can push out the water from the gas collector bottle. So, the displaced water comes to the water displaced bottle. Finally, I tested the collected biogas flame using this. Thank you for watching.